I had myself muted. Okay. I put a video up dealing with a few little minor things in Adobe Audition yesterday, and I got a little bit of feedback on it. And first off, let me say some of the things that I talked about, there's multiple ways of doing it. Some people do it different ways, and you'll find if you ever get in a professional setting that pros, broadcast engineers, sound engineers, each one, they're individuals and they have individual ways of doing things. They like sounds to sound a certain way, and they like audio to be their particular way. When you listen to record labels or listen to certain singers who deals primarily or strictly with one individual that they like it because of the character that each person puts in what they do. A studio operator and a sound engineer, when they do something with the track that the artist, I keep adjusting myself so it sounds better in here. They when they find one that creates a sound that artist likes, they tend to stick with them. And the reason that they're able to do that is because each engineer, forgive my phone, each engineer, they have certain ways of doing things. They like certain effects, certain plugins. They like to do things a certain way. And that colors the end result. And none of them are bad, and they're all good, just different things come out with different ones. And so I'm not attempting to say that what I say is the end all be all. It's not. As a matter of fact, some of you know easier ways, quicker ways. Some of you have effects, templates, or whatever you want to call it, stacks. And all that's great. That's fine. A lot of people don't do that. I have a particular template that I use, or an effect stack, as some people call it, for myself. But now you won't hear it on this. This is just raw audio being recorded into XSplit. It's what I use to stream video and to actually screen record here. I don't use a quote unquote screen recorder. I use my streaming software to record to the hard drive when I'm doing video like this. And so what you're hearing is what's going into that. I've got Adobe Audition up because I'm going to show something else today. But what I wanted to say at the outset is what I'm not trying to tell you that this is the way. I'm trying to show you some ways to get started with Adobe Audition, because a lot of times when you bring this up, if you've never recorded and never done any kind of processing or editing of an audio file, a lot of the things that you'll see will be confusing. And I'm going to take this down and I'm going to just bring it up. Now, of course, I've got a particular window set up now, or setting for my workspace. Normally I have it on two monitors here. I'm looking at two monitors. So normally I do it that way, but since I tried to record it that way, it squishes everything down so it can be seen on one, and it doesn't look good. So now I've squished my Audition workspace back down to one monitor for the purpose of recording this. I'll get it out in a minute. When you bring it up, and I've got it set to run as administrator, and I suggest if anybody's going to run Audition, set it to run as administrator. And while I'm here, it's a good thing to do. If you don't know how to do that, yeah, I'm running Windows 10, so if you Windows 7, Windows whatever, they'll all be basically the same. You go to wherever the icon is. If you're on Windows 10, you just click the little, what used to be the start menu, and right click on the icon. It'll bring you up a list of things here, and click, or just hover over more and go over here and click run as administrator. Now, when you do that, it's going to set it. Now, if you have it like me down here, right click on it down there, and let's see, you can do it from here too. You have to right click on it here and then right click on it there, and you can do run as administrator. Let me show you another way. Go into your, wherever you have it. I didn't think that was it. Wherever you have your program file stored. And now here you see, there it is. If you right click on it there, you'll get this list here. Now, if you're running it with where you have it, an icon up here, just on your desktop, if you right click on that icon, you're going to come up with a menu box similar to this. Click on properties. When you click on properties, well, it's not showing. Ain't that lovely? I can't remember exactly how it is on like Windows 7, but when you click on the icon, you'll get a set of options up here, and one of them will be compatibility. If you click on that, under compatibility, you'll look down and you'll see run as administrator. Tick that little checkbox. And that's basically what I've got it set to do. I know that was probably unneeded, but there you have it. Now, we bring it up here, and one of the questions that I had is the video I put up yesterday. When I mix down, well, if you look at it, the waveform, when I'm recording my voice through the equipment I've got, there is something that some people have confused with a, I don't know why that keeps popping, confused with a DC offset, a direct current offset. When you're recording into a digital workstation, you'll come up with a waveform that looks like this. You have what some people refer to as a center line or a bass line. And it's usually represented in your sidebar over here as with the infinity symbol. And when you talk or when you record, or if you bring in an audio file and put it in there, you'll see a waveform similar to this. And you have amplitude. Now, amplitude is AC voltage. When I speak into this microphone, the diaphragm vibrates, and there's a coil wrapped around a magnet. And when that coil moves around the magnet, it creates a current within that coil, which is where all this signal and all this comes from. What you're hearing is basically because there's a coil and a magnet, and that coil is moving around that magnet or within the field of that magnet, and it's creating a current, and it's creating an alternating current. Alternating current has both positive and negative properties. The positive properties of the current, or the waveform, is represented when it goes above the baseline. The negative properties of the waveform is represented when it comes below the baseline. You have positive, you have negative. And from this peak to this peak represents your amplitude. The amplitude is how loud we are, or it can possibly be referred to as, I don't want to say this, but I'm going to say it, your dynamic range. You know, the dynamic range is not from peak to valley. Your dynamic range is from peak to peak. So there you have it. Now, RMS amplitude is measured. If you can kind of look here, the darker, more solid parts of the envelope, you can see how they're squished down, and you have a lot of peaks, and you have this squished down sort of darker. I know I'm using, bathroom terms or whatever, but to get you to see what I'm talking about, that is where the majority of the information that we are going to hear sits in this waveform. All of this extra stuff up here, these peaks, it contains information, but it's not as audible. It's less information, and it's actually causing it to be where, because we don't want to go over 0 decibels full scale, of amplitude, we can't bring up the average or the RMS, the root mean square amplitude. We can't bring that up to where we want it to be, that it increases the loudness, because we have these spikes that won't go past, well, they will go past 0 decibels, but we don't want them to, because when they do, you really hear them then, especially in the form of distortion. So you want to keep the peaks, you want to keep this waveform from exceeding 0 decibels here or 0 decibels here. Now, somebody has asked me why you have negative numbers here and negative numbers here. It's because you're coming from the baseline. This is infinity, so to speak, your baseline. Your waveform comes from this. Now, as you increase this way, it's basically the measurement scale. At minus so many decibels, a sound is you can't hear it. You can't perceive it as being there. We can't. And as you increase in volume, you're going more toward the 0 decibels. 0 decibels, we could say, is unity. That it would be the loudest point where we want it to be. As far as getting into the science of why it's 0 decibels, whatever, there's people that can do that for you, and we'd love to explain it to you. But 0 is the mark we don't want to go past. That's the loudest point. And because dropping below this baseline, what we understand is below it into the negative area, is not going more negative. It's actually getting less negative as it regards the baseline. Anything below the baseline here is the negative part of the AC or the sine wave or the AC waveform. Anything above it is the positive side of the waveform. But as far as amplitude is concerned, if you'll look right here, this entire, what you have on both sides of this baseline equates to your amplitude. So anything that leaves this baseline in either direction is increasing the volume. That's why you count down going up and you count down. Am I right? Yeah, whatever. Going down. So, but hopefully quick, probably more confusing answer than ever before. But now the question was asked about, let me move this back over here. Let me show you, let me bring it up on Audition right quick and I'll show you something. I'm just going to record a quick, I don't like that, so we'll do that. Okay, testing 1, 2, 3, 3, 2, 1. This is Billy Martin with Blurred Line Media Group. How you like that? P. Okay. I'm going to knock that off. I'm going to knock this off just because. Now, if you notice something, I'm going to blow this up a little bit. My baseline is right here, marked by the little infinity symbol. If you'll notice, my peaks in the negative side, the negative area, go way further, just say minus 7 decibels. My tallest peak, so to speak, is only about minus 13 decibels up here. Why? Well, it's got to do with several factors. Some of it is the equipment I'm running. Some of it is my voice, which has more in the deeper end. It has less positive pressure. If I were to speak in a more forceful manner with a little bit higher pitch, you would literally see this waveform scoot up more centered on that baseline. But I'm actually running a couple of, I'm running a hardware processor for this Shure SM7B, which is a very quiet, very, very gain hungry microphone. I'm running almost 60 decibels of gain on the mic, and I'm processing it with a very little bit of compression. And I've got a de-esser running, and I actually got a little bit of a vocal enhancer going on here. And I have an expander that I'm using for a noise gate. Anyways, so that adds to this, what you see here. Now, if you go into Adobe, Effects, Noise Reduction and Restoration. No. Yes. No. My bad. I'm sorry. Normalize. You see this right here where it says DC bias adjust. Now, a lot of people like to click that and put it at 0% and apply it. Now, if you see what happened, I increased a little bit here and a little bit here because it was set at -6 decibels. But it did not remove this offset because this isn't a DC offset. What you're seeing here is not a DC offset. Now, let me undo this. Let me show you what a DC offset looks like. It looks like this. Here's the baseline. Now, you can plainly see the baseline on this waveform would run right through here. Now, if you run a DC offset on this waveform will drop right down here on the baseline. This is a DC offset, not this. So what do we do about this? I'll show you in a minute, but first you need to know what this actually is. This is an asymmetrical waveform. Don't worry, I have a picture for that too. This is and actually what you see here is just basically this, except the majority of the information, the majority of the signal is in the positive area of the envelope. This is produced, you can produce this with a higher pitched voice, a more forceful voice than what I have. One with less deeper tones in it than what I have will produce an asymmetrical waveform similar to this. Musical instruments such as a trumpet, where it takes positive air pressure, in other words, pressurized air to make that instrument make sounds, will create sometimes an asymmetrical waveform with more of the peaks or more of the information in the positive side of the waveform. If you look at mine, we have most of my voice here in the negative side. This is what's called an asymmetrical waveform. Now, there's several things that can cause this. Let me bring this back. This is bad. This is caused because there's this DC voltage somewhere in your hardware, and DC voltage is leaking into the signal chain, and it causes this, a DC offset. And so you can fix that, and when you fix that with that DC offset in the normalize in Adobe, you'll get this. It took that offset, it took the waveform and just brought it down here and centered it, put it on the baseline. But what we see here and what you saw on the video yesterday was not DC offset. It was this, asymmetrical. How do you fix an asymmetrical waveform, and can you do it in Adobe Audition? I read yesterday that you could not do it, but I knew that you could because I know how you can fix it. You can do it with EQ. Believe it or not, you can fix this with EQ. I'm going to fix this with EQ, but first I want you to hear this. Okay, testing 1, 2, 3, 3, 2, 1. This is Billy Martin with Blurred Line Media Group. Okay, testing. Okay, so you heard that. Sounds, I guess, like me. I should adjust everything so I know what that sounds like to you, but I didn't, so I hope it was okay. If you want to fix it with EQ, you're going to have to run a filter. And I used the parametric equalizer, and I've got it right here, just a generic high-pass filter. And let me show you what happens. Apply it. Look at there. It centered it on the baseline. But listen. Okay, testing 1, 2, 3, 3, 2, 1. This is Billy Martin with Blurred Line Media Group. Okay, did you hear what happened? Listen again. Just listen, and I'm going to switch it back. Testing 1, 2, 3, 3, 2, 1. This is Billy Martin with Blurred Line Media Group. Okay, testing 1, 2, 3. Did you hear that? When I fixed that asymmetrical waveform using the EQ high pass filter, what happened? It took the bottom end and scooped it right out of that waveform. You may like that with no bottom end. I don't. And it's my voice, and I want it to sound like I want it to sound. I like the bottom end in it, so I want it to stay. And I didn't like the way it sounded when it just scooped all that bottom end out. It made me sound like a 15-year-old, or whatever. But I didn't like that. So are we doomed to leave it like this? And you say, well, will this cause a problem? If you can get it loud enough without distorting it and it sounds good to you, it's no problem. Leave it alone. The asymmetrical waveform isn't inherently bad in and of itself, but can it be a problem? Yes, it can. And let me show you how. If we had a file and we run it and there's no noise in it, it sounds good. It just needs to be normalized. Okay, that's great. So let's normalize the file. We would go here, and I'm going to take that off because we don't have a DC offset. And I want to normalize it to -1 decibels because I want to be loud. And apply it. Well, look, I'm not even near. Here's -1 decibels. You see this? You see all this empty space? What happened? It's because I reached -1 decibels down here because I have my waveform is asymmetrical and it's sitting below the baseline because it's got that bottom end or whatever. And so it got down, but now I can't go any louder. I could use compression and I could severely compress it and knock that bottom end off and go ahead and amplify it. But that will make it sound unnatural more so than anything else, in my opinion. This is subjective. Sound is subjective. I'm not saying that is the end all be all. In my opinion, it makes it sound too unnatural. So we don't want to do that. So can we fix this without scooping the bottom end out? I don't know why this stuff wants to pop up when I'm doing something. Okay. The answer to that is yes. Can we do it in Adobe Audition? Yes. I saw a couple of things as I was looking at it. Somebody said, well, you have to use RX7 or RX6 or whatever to fix this. Adobe Audition is costing right now, I don't know. You can get this program probably for $20 a month. I'm not sure. I have the whole suite of apps, and it's pretty expensive. It's about $79 or $80 a month. But I use Photoshop and Premiere Pro and After Effects as well, and doing some graphic design and logo work and things like that. So if you're not using all that, you don't want you want this program. This program run you maybe $20 a month. RX7, if you're going to get the kind of the and I have that. I have the what's it called? RX7 standard edition or standard suite or whatever it's called. It's probably $400 or $500 to get that. $600. I don't know what it is now. It goes way up into the money. The isotope products get very expensive. They're very good products. Don't get me wrong. Isotope makes extremely good products. And if you're going to do this on a more of a professional level, I highly suggest purchasing Isotope, some of their products. But do we have to have that? Can we fix this in Adobe Audition CC 2019? The answer is yes, you can. You go to Effects and go down here to Stereo Imagery, and you want to select Graphic Phase Shifter. Now, when it's set at default, that's what it's going to look like. Now, what causes this? What causes an asymmetrical waveform is differing phases within the same waveform. That's about as complicated as I want to get that if you're an RF engineer or you're a sound or a broadcast engineer, you may have gritted your teeth when I said that, but listen, we're not giving engineering courses. We're trying to make simple explanations that the majority of people, especially newcomers to this, can understand when they see this. And they try. I've had I don't know how many people, and I've seen it on what's that other program everybody uses? Audacity. When you do their normalization, it has an option for DC adjust, DC offset adjust, or whatever. A lot of people have sent me files that says, "Look, this is offset," and I've done I've tried to adjust the DC offset, and it doesn't work. It doesn't move, because this isn't a DC offset. So that's why I'm doing this, to explain what this is. This is caused by differing phase, or let's just say you have a lot of different phase issues going on. Phases are just bumping into each other. Phase, bump, bump, bump. And it gets, instead of, I can't do it where you see it. Instead of doing this to make a really pretty sine wave, you've got all these artifacts and all these different sounds and frequencies and things being introduced by all this equipment, hardware, software, processors, just all kind of stuff. Well, things get switched out of phase, and it causes some of this junk. I hope y'all like my little doodads. I don't know, whatever. Anyway, this is a phase problem. Let's put it that way. How do we fix it? With a phase shifter. Some things call it, what is that? Phase rotation, or I forget what they call it. Anyways, we're going to fix it with this. Now, you got options here. What do you want to do? Well, let me explain first. We want to shift the phase. And since my problem seems to be that I've got too much of my waveform sitting in below the baseline, I want to shift my phase positive. How much do I go? Well, let's see. If I shift it plus 90 degrees, let's see what happens. Okay. We moved it up. That looks okay. It's okay. I would probably leave it with a plus 90. But if you wanted to adjust it manually, I'm going to show you that as well. We click on it, and say 90 degrees, plus 90 degrees was too much. Let's use 80. Let's do about 75. Basically, just slide both ends. Oh, great. And then there we go. Oh, man, look how wonderful. It fixed it. 75 degrees plus 75 degrees was perfect. That's how you fix it. But now, let's go all the way back. Let's undo the normalize. Now, listen to it as it was. 3, 2, 1. This is Billy Martin with Blurred Line Media Group. Okay. You remember what happened when we applied the EQ, the high-pass filter with the EQ, and it fixed it. It made it less asymmetrical, but what did it do? It took the bottom end out of it. It sounded higher pitched, thin, empty, whatever you want to call it. I was having a mid-range party with that high-pass filter. But let's fix it with the phase shift tool. Let's do it. I'm going to use the 90 degrees. That actually really did look better to me. Okay, now we fixed it. Now we're less asymmetrical. It looks more symmetrical. Let's see if it took the bottom end out. Okay, testing 1, 2, 3, 3, 2, 1. This is Billy Martin with Blurred Line Media Group. Okay, testing. See, it sounds like it did originally. It didn't take the bottom end out. That's how you actually fix it. If somebody is fixing an asymmetrical waveform with either a high pass or a low pass filter, they're not really fixing the problem. They're just moving the problem into a different area. And if you're asymmetrical above the baseline and you use a low pass filter to force it down, it will look better, but it will sound worse. If you're below the baseline, like my files usually are, and I use a high pass filter, it will visually fix it on the screen, but what you're going to hear is not going to sound good. To fix the problem, both visually and without causing any problems audibly speaking, you want to shift the phase. You need to use your phase shift tool. Remember, effects, stereo imagery, graphic phase shifter. That's how you fix an asymmetrical waveform. Thank you all. I appreciate it. I hope this helped you. I know I wasn't very technical, but I didn't intend to be very technical. I want to make this where people can understand enough to work with this program. I think Adobe Audition is probably, in my subjective opinion, the best tool for this job, especially if you're a podcaster. I think this will go a long ways for you, and you won't outgrow Audition, I don't figure. I really like the program, and I'm still learning things. I don't know everything about this program, but when I learn something, I really want to show people how to use it. Surely appreciate it. Thank y'all. And we'll be seeing y'all next time.